So today we're going to be adding, subtracting, and multiplying polynomials. Yay! Remember, when you add or subtract polynomials, when you add or subtract anything, you can only add or subtract things that are like terms. So with polynomials, if the terms have the same variable to the same power, you can add or subtract them. We're going to go over how to add or subtract vertically or horizontally, and then you can choose which method you prefer. I'm just going to show you both methods. So the vertical method says to first write 3x squared plus 3x cubed plus 2x squared minus x minus 7 over x cubed minus 10x squared. So we got plus 8. When I write that plus 8, I'm going to line it up with the term that it has likeness with. What am I going to put the plus 8 under? The minus 7. I'm going to put the plus 8. I'm just going to leave a space. And we're going to add those. This is the vertical method. When you do the vertical method, you should purposely put your like terms on top of each other. So it makes it a little bit easier. I'm going to add these together, and I'm going to have 3x cubed plus x cubed. Those are like terms. So I have 3 in one hand, and I got another in another hand. What happens when I put them together? I now have 4. 4 of what? I have 4 what? X to the third. Because when you're adding, it doesn't change the exponent, it just changes how many you have, the number in front. What would change the exponent? Yeah, if you multiplied by x's, but we're just adding right now. So we're going to add these, we're going to get negative 8x squared. I'm going to add a minus x with nothing, so minus x, and then plus 1. Adding like terms, vertical method. Adding like terms, horizontal method. So horizontal method, you keep it in like one line, and you have to figure out what like terms with what else and add them together. I like to use symbols. For example, maybe I'll put a square around 9y cubed, and then I'll look for any other like terms with 9y cubed. Is there any other like terms with 9y cubed? I do not. Okay. Then maybe I'll put a circle around plus 3y squared. Do I have any like terms with plus 3y squared? Minus 5y squared, okay. So those get the same symbol. And for minus 2y, maybe I'll double underline minus 2y. Do I have any like terms with minus 2y? The plus y? Probably a bit the same symbol. And then plus 1. Ooh, I'm feeling squiggly line. Feeling squiggly line. And do we have any like terms with plus 1? Minus 4. So now I'm just going to add together the terms that go together. I'll have 9y cubed by itself because it has no friends. I've got 3y squared minus 5y squared, so minus 2y squared. Minus 2y plus y minus y. Plus 1 minus 4 minus 3. The special pictures are optional. I just feel like when we have a lot of terms, sometimes it helps me stay organized. And it's pretty. So that's the horizontal method. Subtracting polynomials vertically and horizontally. We're going to do this one in vertical format. We're going to read it carefully. This says subtract 2x cubed plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9 in a vertical format. What does that from mean? Which one goes on top? Yeah. Now we are doing subtraction. But when you subtract, you are subtracting the entire polynomial. You are subtracting this whole thing. That means I'm going to subtract each term. I'm going to subtract each one. So I'm going to subtract 8x cubed minus 2x cubed, which is 6x cubed. Then I'm going to take negative 3x squared, and I'm going to subtract 6x squared. So now I have minus 9x squared. I'm going to take 2x, and I'm going to subtract negative x. What happens if I subtract negative? It becomes plus, doesn't it? So I have a minus 2x, and then I have a plus 1x, so it's minus 1x. And then I have a 9, and I subtract a positive 1. So 9 minus 1 is, that would be the vertical method. And when you do your assignment, you can choose whatever method you care to do. I'm going to show you both of them. B is going to be the horizontal format, and this, again, says from. So we will be writing 2z squared plus 3z first. But this is the horizontal method, so I'm going to put them in one big line. And since I'm subtracting the entire trinomial that is written second, then I have to subtract each term. I have to subtract each term. So I have to do 2z squared plus 3z minus 3z squared minus z, and then plus 4. So I have to change all of those signs. And we're going to combine our like terms. Is anything like term with 2z squared? Yes or no? Like terms? Yes or no? Yes. Negative 3. Z squared. Add them together. Negative z squared. Why did I say add? Are we subtracting? Why did I say add? Subtracting is like adding the negative. Yes, what you said on the answer sheet. Where I was subtracting a positive, that's like adding a negative. It means the same thing. Okay. So then 3z. Any like terms with 3z? Yeah, minus z. So 3z minus z is positive 2z. Why did I put that weird thing on my z's? It doesn't look like a 2. Because I can't tell you how many mistakes I've had a grade on tests where somebody thought it was a 2 and it was really a Z. Just get rid of it. Happens all the time. Okay, we're just going to skip over this to your practice if that's okay. You guys have done this quite a bit, I hope. Let's go to multiply. Back in the day, when you first learned to multiply more than one digit number, or even one digit with a longer number, we multiplied in a vertical format. So we're going to revisit that for a moment, and you don't have to do it this way if you don't prefer this method. What?
I didn't say last time.
It's been a while. So let's go over what you do, because guess what we're going to do on Thursday? No. Let's see. Today we're doing addition, subtraction, and multiplication. We are doing long division. How else are we going to divide polynomials? You, please divide these on the calculator. You can't do it on the calculator. I'm waiting for Reed to figure it out. I can type in X's and stuff. Yeah, that's not right. So the alpha X on your calculator is where you can store a value of X, but it's not actually a variable X. It's just like X might be stored as 20 on your calculator. So it would use the value. It wouldn't do it like that. Alright, so the vertical format is actually not much different than horizontal format. Vertical format means you're going to take this minus 3 and you're going to multiply it by all three terms that it's under. So you're going to distribute the minus 3. You're going to distribute it. And negative 3 times 4 is negative 12. Negative 3 times 2x is negative 6x. And negative 3 times negative x squared is positive 3x squared. Then we'll take x and distribute it to everything above it. X times 4 is 4x, but what am I going to write it underneath? The thing it's like terms with. Then x times 2x is 2x squared. And x times negative x squared gives me one more exponent, so negative x cubed. Then when we did this way back in the day, when you learned how to do this, you just added your like terms. Only your terms back then were tens and hundreds and thousands. Now, really? I think this is easier, but okay. I'm just adding 5x squared, negative x cubed. That's the vertical method. You can also do it horizontally. So let's do the horizontal method. Horizontal method means write y plus 5 and another parenthesis right next to it. And it's a lot like the FOIL method, but it's the extended distributive property. We are going to distribute the y to all three terms in the other parentheses. We're going to stay organized, so I'm going to have y times 3y squared. That becomes 3y to the third. Y times minus 2y, so minus 2y squared. Y times 2 is plus 2y. Then I distribute 5 to all three terms. And I like the vertical method. So you will see when I do 5 times 3y squared, I get 15y squared. I'm going to put it underneath. But you could, if you want, put it in one big line if you like the horizontal method. But I like the adding up and down part. Then I'm going to do 5 times negative 2y, so minus 10y. And then 5 times 2 is plus 10. We collect our like terms, 3y cubed plus 13y squared minus 8y plus.
Do you ever like it calls to solve by a certain
To do what?
to solve like by vertical or solve by?
No. I will not specify that you have to do vertical or horizontal method. You choose. I will say that I was always taught to do it horizontally, and then when I was introduced to the vertical method, especially adding like terms, I like it so much more. So I choose to show you those methods because I actually like this way better, even though I was always taught the horizontal way. So that's why I'm choosing to show it to you, but you can do it however you want. Now our next section is multiplying 3 binomials. Before we multiply 3 binomials, I'm going to give you something really easy. How would you multiply just 3 numbers? 3 times 2 times 3. 2 times 3 times 4. What would you do? You do 2 times 3, which is 6, and then you do 6 times 4. So you would have to find the answer to one of the, or 2 of them first, the product, before you multiplied those together. And with multiplication, did I have to go left to right if it's all multiplication?
No.
Not if it's all multiplication. I could go in any order. So I could do 3 times 4 first, 12 times 2. Or I could do 4 times 2, 8 times 3. Like, you could multiply in any order you want, but you have to do 2 of them. Take that answer, multiply by the third. Same thing. X minus 1, x plus 4, x plus 5. Which 2 would you like to do first? Your choice. The 4 and the 5? Okay. How do we multiply something like that? How do we multiply it? Distribute. For the method. Remember we spent a lot of time factoring on multiplying it. It should be really easy to multiply back together now. What's the first term going to be? X squared. My outer and my inner gives me 5x and 4x. So 9x. And then my last gives me 20. Now we have to take that and multiply it with the other term, or the other binomial we skipped. So now we're going to distribute x to all 3 terms. When you distribute with an x, that changes the exponents. So I'll have x to the 3rd plus 9x squared plus 20x. Then I will distribute -1. -1 times x squared is -x squared. I'm choosing to put that under the 9x squared so that they're already like terms. -1 times 9 is minus 9x, and then -1 times 20 would be -20. You gotta go there. Sure. Sounds something I need. What was I gonna say? Oh yeah. So just heads up. After Thanksgiving, after we come back, we're gonna be given this and have to go back to that. So practice this good because you're gonna have to. All right, the last page has some shortcuts, but I'm going to tell you, shortcuts don't work unless you remember these horrible-looking formulas. I don't really use the shortcuts very much. If you could come up with your own shortcuts in your head after practice and practice, that's great. So I just say we practice normal. So I'm going to skip ahead to number 6. And can you try number 6, anyone? We are being very careful, aren't we? Thinking about what we're multiplying together. Most of us are being careful. Good job. What's 4 times 1? I mean 2 times 2. No, actually 8. No. So we did this one, and that one, and this one, and that one. So that one should be it. Okay. So 9t squared minus 4. Do the next one. You didn't do 3 times 2. I only did 3t. Try number, what's next? 7. Try number 7. If you feel like you got that one, try 8. Eight's really the test if you understand it or not. I put up the answer to 7 so you can make sure that you did it right and that you didn't kill any puppies. Number 7.
Nobody killed puppies with it. All the class did.
So I already see a few mistakes on number 8. Be careful. When you do xy times xy, that's x times x and y times y, which is x squared, y squared. And then minus 3xy plus 9. So x squared, y squared minus 6xy plus 9 for the first two. You have to take that product and you have to multiply it by another xy minus 3. So when I do xy and I multiply that by x squared, y squared, that ups the exponents for the x's and the y's. I get x cubed, y cubed. Then I take xy times minus 6xy and I get minus 6x squared, y squared. And then xy times 9 just gives me 9xy. This is the very last question on that packet. So we take negative 3 and distribute to each term. We're just multiplied by negative 3, no exponents change. Plus 27x, nope, that's not 27, it's 18. Then minus 27. Can we get one? Can we get one for somebody near you in the numbers? If you need the numbers, the assignment numbers at home, if you need the actual book numbers, I put them up on the board. But the assignment is on Big Ideas this time. Just gotta be careful about those checks because you can easily make a silly mistake with a negative here or there. So I can put it back up. I turned off my video.